This is a circle and this is a point. A tangent is a line that touches our circle once. And now I'm going to draw another tangent. Now these two tangents come from the same point. So we say these two tangents are equal, meaning from here to here, and then from here to here, we have the same length. Before we can start proving Theorem 8, we need to start from Theorem 7, which states that a tangent to a circle is perpendicular to a radius at point of contact. Meaning, if you have a circle and a center, and then you draw a line from the center towards the circumference, and there's a tangent, a line that touches the circle once, then that line is perpendicular to the radius. We're going to need this theorem to prove Theorem 8. We don't necessarily need to know how to prove this one, so that's why I'm not making a video on it. We are starting from Theorem 7 in order for us to know how to prove Theorem 8. Now, Theorem 8 states that tangents to a circle from the same point are equal. So we are required to prove that length AB, meaning from the point of origin of our tangent to when it touches our circle, is equal to length AC, from the point where our tangent originates to when it touches our circle. Proof. Construction. Join OB and OC. You use dotted lines for construction, so we just joined OC and now we are joining OB. Then again, also join AO. Now we are joining the center of our circle with the point where our tangents originate. So by doing this, we have created angle O1 and angle O2. Let's call these angles angle C1 and angle B2, so that we don't have to call them angle OBA. We will just say B2 instead of saying angle OCA. We will just say angle C1. Yeah. Remember our very first theorem, we had to prove that two triangles are exactly the same to one another. Meaning when they are exactly the same, their lengths are equal and their angles are equal. Well, in this theorem, we have two triangles again. And yes, we must prove that they are congruent. Why? If we can prove that this triangle OCA, is exactly the same in terms of size, lengths of sides and angles to triangle AOB, then we can just easily say AB, which is a side of this triangle, is equal to AC, which is a side of this triangle. So let's prove that these two triangles are congruent to one another. For proving congruency, we just need three reasons. So we can either prove that all three sides of these two triangles are equal, or we can just find a right angle in each triangle. So in triangle AOB and triangle ACO, so our first reason, I don't want to hide this diagram. Our first reason, when you look at side OA, it is a side that is shared by both triangles. So there's no way one triangle has OA that is longer than the other triangle. So OA of triangle ABO is equal to OA of triangle OAOC. Side OA is equal to side OA. Why? Because this is a common side. Reason number 2. Now remember Theorem 7, it stated that whenever you draw a line from the center of a circle towards a tangent, that line is perpendicular to what? Why light it dim? What the hell is going on, man? What the? Evanna. Light you freely. Kind of what was I saying? In Theorem 7, we saw that whenever a line is drawn from the center of our circle towards a tangent, then they form a 90 degrees. So in this triangle, we have a line from center towards the tangent, so we have a 90-degree angle. And also in this triangle, this is bad, man. We have a line from the center to the tangent, and it touches the tangent at point C. So therefore, angle C1 is also a right angle. Our second reason. That's xenophobic. Okay, exactly. The phone call. That's xenophobic. Amen. Yeah, I get distracted. Yo. Reason number 2. Angle B2 is equal to angle C1, and both angles are equal to 90 degrees. Why? Because we have a tangent that is perpendicular to a radius. Now our third reason. Let's look at our diagram. We have OB as a radius, and we also have OC as a radius, and you know that radii are always equal in length. So OB is equal to OC. Why? They are radii of our circle. So now we have three reasons. We can conclude that triangle AOB is congruent, 3 parallel lines, to triangle ACO. Why? Because we have a right angle, a hypotenuse, and a side. We have right angle, hypotenuse, side. Therefore, if these two triangles are exactly the same to one another, meaning this side of this triangle is equal to this side of this triangle, this angle of this triangle is exactly the same as this angle of this triangle, and so forth, then we can conclude that AB of this triangle is equal to AC of this triangle because they are congruent to one another. Therefore, AB is equal to AC. We have proven that tangents from the same point to a circle are equal. This is the end of this terrible video. Thank you for watching. I hope these people are watching, man, even though it's low. We have technical load shedding. It's easy to see when you look at me. If you look closely, Mystic don't back down. Subscribe to this channel if you haven't already, so that you can get that A in mathematics. Leave a comment down below if you have a question. Mystic will make sure you get the answer. Leave a like and share this video with your friends, so that we can all be good. Thank you for watching.